All, welcome to the Web Application Challenges section on Pentester Academy. In this video, I will show you the solution for Challenge 8, Broken Authentication. So let's head right back to the challenge. Let's open up our little friend Iceweasel. And this challenge is really based on the cookie lessons which you guys may have taken on Pentester Academy. So what I'm going to do first is actually go ahead and set up the proxy. So I'm going to go in here, manual proxy settings. This is so that we can run burp. And what we are going to do is, by default, burp only intercepts requests but allows response to go back as is. We will tell burp to intercept responses as well from the server side. Why? Because typically set cookie comes from the server, and hence you would like to know what cookie the server is setting so that we can work on it further. Let's wait for our friend burp to start up. Okay, so we'll go to the proxy tab. Let's go to options. And if you scroll down, you'd see intercept server responses. Go ahead and enable that so that now both request and responses are enabled. And then we can go back in here, type in the URL of the challenge. And this is intercepted in burp. So let's go ahead, forward this, and let's wait for the server response. And if you notice, the server response seems to be user underscore ID. If you notice, the set cookie part is TUE9PQ equals. Now, if you remember, basically, the basic authentication exercise, then the equals really points to some sort of base 64 encoding. So let's see what happens if we try to decode this. So let's send to decoder. Decoder lights up. Let's go in there, and let's decode this as base 64. Still nothing substantial. We have MA equals. Again, when I see equals, I get a hunch that this has been probably recursively base 64 encoded. So let's go back in here, again decode this as base 64. Aha! So the value after the base 64 decoding 2 times is really 0. Okay. And if you go back to the proxy tab, it basically says user underscore ID equals, and then this evaluates to a 0. So let's try and set it to the next number. Probably 0 is for the guest anonymous user. The next number could be increasing. So let's actually set this to 1. And let me actually say encode this back into base 64. That becomes MQ equals. And encode this back again for the second time into base 64, which actually makes this TVE9PQ. So let me go back in here and basically remove this, paste TVE9PQ, and let me go ahead, forward the request. Let's now remove intercept on, go back in there, and let me try accessing the URL once again so that our new updated cookie goes. And there you go, right? So the whole challenge banked on the fact that the developer thought that if he's going to double base encode information, which he unfortunately seems to use to authenticate the client, then nobody would notice. And I think a lot of developers have this misconception that things like cookies cannot be viewed and tampered by pen testers or anyone with malicious intent in mind, right? So the key learning is do not store anything in the cookie which you go ahead and use for authentication without running any further verification checks on the server side. The mistake here is not using the session cookie or the user underscore ID equals something as part of the cookie. It is rather that the server application simply relies only on what is there in the cookie for authentication, right? Fantastic. So that is all I have in this video. If you have an interesting solution, please do post it. You can tweet to us. And if you like what you see at Pentester Academy, please do recommend this to your friends and colleagues. The success of this initiative greatly depends on the number of people taking it. And you can always go ahead and tweet to us or connect with us on Facebook. That's all for this video. Thank you.